web development requires more than just state management, it requires effect management. The two can be complementary, like the black and white keys on a piano. In this video, you'll see how to use Omnibus-RxJS to manage effects outside of the XState state management library. Let's dive in. Here we have a counter managed by XState. I click the increment button and the count field managed by XState increases. Now, what if we want to play a sound upon each click and display a visual indicator while it's playing? Let's start simple. XState supports actions, and here we have a function that plays a bell sound with the Web Audio API. Let's hook it up to XState via the actions field of the increment event. We click the increment button, and nice, it plays the bell. It even plays overlapping bells, but we'll get to the options for managing that in the next video. But what about that visual indicator? Should we have a state or context field is playing to control whether it shows or not? Here are a couple of reasons not to put that field in XState. One, it's not dry. The actual running effect is the source of truth whether the indicator should show. The state field is redundant to that. Two, it could be inconsistent. What if our state was loaded from local storage? Would we ever want the indicator to be showing on startup while a bell wasn't playing? An Omnibus service can let us know directly when our effect is running, clearing up both of those. So let's see how that works. First, an Omnibus service requires an instance of a bus, an omnibus. We start with a file that creates and exports an instance of a bus. We listen to all its events with a spy, logging them to the console, and also any of its errors. Now, we can create an Omnibus service that lives on that bus. We'll call the service ringIt, and we'll invoke it like a function. To create the service, we call createService from Omnibus-RxJS. We declare the service's namespace to be bell. We give it a reference to the bus, and we assign our bell playing function to be its handler. Back in our counter, now we can call ringIt from the increments list of actions. Let's give it a shot. Push the button, and great, it works like before. Now, how about that indicator? Well, we have in our markup a bell indicator with the ID is ringing, starting off with the class is hidden. Let's see what our service gives us to add or remove that class. Our ringIt service exposes a property is active, which is an observable. All we have to do is subscribe to this is active property and remove is hidden from the class list while active. Let's see how this goes. Nice. But do you see how at the end of the sound, the indicator doesn't go away? We haven't told our service when we're done. It's a philosophy of Omnibus that you should return the work rather than imperatively call a function from a listener. We should return a promise or an observable that represents the complete work that will enable our isActive indicator to turn both on and off. Now, let's wrap our work in a promise. We don't need any advanced features yet, so we won't use an observable. The onEnded property of the audio source is when we should resolve the promise. Let's make that change. And now we click the button. If we look at our console, we see that the bell complete event fires only when the bell is done ringing. This is great. Now, let's complete our isActive updating code. Now, we click the button again. Indicator is on. And voila, our indicator is off when the effect is done, only showing while the effect is running. In summary, this is a clean separation. Effect management triggered by state management. XState's actions get to stay simple. and our effect management stays focused on what it does best. In the next video, we'll address two other powerful things Omnibus listeners can do: queue up the sounds and cancel them using the power of observables over promises. Thanks for listening.